Welcome back. Today we will be talking about evaluating limits, that is nothing but the removable discontinuities with the trig functions. To understand it a little bit better, we need to understand three main properties. Limit as x approaches to 0, sine x over x will give you a 1. Limit as x approaches to 0, 1 minus cos x over x will give you a 0. And the another third property, which is not that often seen in the textbooks or often overlooked, is limit as x approaches to 0, tangent x over x will also give you 1. So these are three basic main properties that will really help you to evaluate the limits. So let's start with question number 1. If you look at the function, this sine pi half minus x, this is nothing but the cos x, because pi half is nothing but the 90. So sine 90 minus theta, or 90 minus x, is nothing but the x. So if I rewrite this function, this limit again, it will be limit as x approaches to 0, 1 minus cos x over x. And that is the same thing what we discussed earlier. This is nothing but a 0. So if you are able to recognize the properties well, then things will get easier. Now again, cos pi half minus x is again, it is a sin x, right? Because it is 90 minus theta. So limit as x approaches to 0, sin x over x, nothing but 1. But why and how it works? Because sine and cos, they are complementary function, right? And what are complementary angles? The angles that add up to 90 degrees. So that is why this will work. So sine pi half minus x will be cos x, and this will also work. Cos pi half minus x is sin x. Now question number 3 can be solved with the property that I told you, that limit as x approaches to 0, tangent x over x will be 1. But your teachers might ask you to do it in a more detailed way. So the more detailed way will be tangent x can be converted into sin x over cos x and times 1 over 3x. Now, I want to convert sin x into sin x over x. So let's write x here, and then I will also multiply by x in the numerator. Because we are just separating, right? We are not multiplying anything. From 3x, I just took the x out. So limit as x approaches to 0, sin x over x, that will be 1, and we are left with 1/3 cos x. So, and we can say 1 times, and let's do the direct substitution at this point. So 3 times cos of 0. Now what is cos of 0? Now go back to the unit circle. Cos of 0 on the unit circle is nothing but 1. So your final answer should be 1/3. It is on the unit circle. So have a good grasp of unit circle. You don't have to memorize it. You just have to learn how to write the unit circle in just 1, 2, and 3. Let's talk about the another way to solve it. We can use, as I said, tangent x over x as limit x approaches to 0. So you can bring x with tangent x, that means tangent x over x, times the limit x approaches to 0, 1 over 3. This will give you just 1 tangent x over x, and you are just left with 1/3. So that is the shortcut to solve this one. If you know the property of limit as x approaches to 0, tangent x over x will be 1. And this is the long way of solving it. So whatever makes sense to you. Question number 4. Now we have sin x, and in the denominator we have sin 4x. So I can rewrite it, these two numerator and denominator separately. So let's take sin x separately, times 1 over sin 4x. So now my main agenda is to bring x in the denominator with sin x and 4x in the numerator for sin 4x. So we will multiply and divide few things. So let's multiply and divide by x. So I will write 1x here and 1x on the right hand side, and then 4x and then 4x, because that way we can get closer to the property that we already know about. So let's rewrite it, the proper limit notation again. So we can write in the three different limit notation. Sine x over x, and the limit x approaches to 0, 4x over sine 4x times limit as x approaches to 0, x over 4x. Here's the thing, whether it is sine x over x or x over sine x, it will result into 1 only. So the first thing, the first limit notation and the second limit notation will give you only 1. So we are left with 1 times 1 times limit as x approaches to 0. See, I'm writing in detail so that to help you understand. But when you are solving it, you can skip few steps. And from here, we can cross off x and x. We are just left with the constant, which is 1/4. That is why the answer is only 1/4. Let's quickly do question number 5, because we will be doing 5 and 6 on from this worksheet as well. Now going back to question number 3, you can do the same thing. Again, I'm reminding you that this property limit x approaches to 0, tangent x over x is equal to 1 is quite important. Now in this one, we can separate the denominator, so we can rewrite the denominator. If we are able to rewrite the denominator in terms of 2x, then we can use the property. So I can write is 2 times 2x. Now let's write two different limit notation. 1 minus cos 2x over 2x times limit as x approaches to 0, 1 over 2, and this is nothing but a 0. So 0 times 1/2 will just give you a 0. Right? Okay. Let's try question number 6. Now sine squared 2x. What does that mean? That means sine 2x times sine 2x. Right? Be very, very careful. Even though the square is on sine, it is technically the square is on the whole entire thing, and then separate x squared into 2x's. Now I need 2 in the denominator, so we will multiply 2 times in the numerator and denominator, and then with another 2 in the numerator and in the denominator. Now I can write it in 3 different limit notation to help us understand. Limit as x approaches to 0, sine 2x over 2x times limit as x approaches to 0, sine 2x over 2x, and one more time, limit as x approaches to 0 times 4. This will give you just 1 and 1, so 1 times 1 times 4. That will be nothing but only 4. So, and this is my explanation for evaluating limits with the trig. I hope it made sense, and I will see you in the next video.